All right, everybody online can hear me?
Yep.
All right, thank you. Okay, let me. There. Start Raspbian up here. Okay, so first off, sorry about Tuesday. I got a call, I don't know, an hour before class saying there was some contact tracing something or other from Ozaki County. They did off like my credit card was swiped at a, I don't know if it's a gas station or something like that. So I may have been in contact, but so I had to go in and do a test, but came back negative, so I'm clean. But I don't know, it seems kind of ridiculous. Like I was basically under house arrest. Well, not really house arrest because my time for the test was like 10:20 a.m. And then it took like 45 minutes. They said it's going to take around 45 minutes to get the results. So I go and do that, but I didn't know how long it was going to be out of commission. So, no. Huh? I don't know. Maybe it's because it wasn't related to Concordia. It was a Ozaki County thing.
Oh, really?
Yeah.
Kind of crazy that they track you through your credit card like that.
Well, on the one hand, it's kind of interesting that, they're doing contact tracing at that level, but on the other hand, I mean, what does that mean? That maybe within a 15-minute period, I was at the same gas station standing outside pumping I'm assuming it was a gas station. I couldn't think of any other situation where I would have been in contact with him that day. So I was standing outside pumping gas during the same 15-minute period or something like that he was there. I don't know. Seems kind of ridiculous, but it is what it is. But I do apologize. So I want to review the find function again. We talked about that last time, but that's a pretty important one. And then we're going to write some, actually, I'm going to do a couple things here. We're going to look at find. I think we've already looked at replace. We looked at the strip function that takes out the spaces by default on either end. We need to look at dictionaries today. We started looking at lists. Combining lists, I probably won't spend a lot of time looking at, but it's in there. I'll talk about this, not that important, but we will talk about dictionaries quite a bit today. Okay. So let's introduce dictionaries first. Actually, let me remind you about the find thing. So remember this find function. If I have a string, like hello, and I want to say a string dot find, and I'm looking for a L. It's going to give me the position in a string where that L is first found, right? So it's going to end, it's a zero index. This is bucket 0, this is bucket 1, this is bucket 2. So this should give me a 2. So there's my 2. Now, what happens if I say find something that's not in there? What do I get? I get a -1, because 0 would be a legal place in here, right? So if it gave me a 0, then that's kind of telling me, oh, the first place I found a Z was at bucket 0 here, where we see is actually an H. So it gives me a -1, which is code for I didn't find it. Now, what I'm telling you is that's the superpower of this function. And we're going to see it in action. Will we see it in action today? Well, we're going to use this function today to solve something. But in any case, this allows you to say, is something part of a collection? Right? Allows you to search for something and get a negative that it wasn't in there if it's equal to -1. If it's equal to something other than a -1, it was in there. Maybe you don't care where it was. You just want to know, was it in there or not in there? Something like that. Okay, so pretty important piece here is that find will return a -1 if something's not in that collection. Kind of put that in your toolbox as that's kind of its main feature, in my opinion. Maybe not that often do you actually care where did it first find something. Every now and then, maybe. But you might be fairly interested in whether something is in or not in a collection. All right, so let's talk about dictionaries. So we've been talking about collections, and so we have one type of collection being strings, right? So these are collection of characters. Then we have this more generic type of collection called lists, where we can have a list that is a collection of characters just like a string, but we can also have a list of numbers. We can have a list of strings, right? So we can have a list that's, you know, a cat, dog, and elephant in a list. So I can create a list, and this guy is equal to, remember, lists are designated with the square brackets, and I can say this guy holds cat, dog, elephant. So now I have a collection of strings. Bucket 0 of this guy is the string cat. Bucket 1 is the string dog. Bucket 2 is the string elephant. If I want to go here and I want to write a loop that goes through all these guys, I can say for I in range 0 to the length of a list. So that'll take I on a voyage between 0, 1, and 2, because the length of a list is 3, and range says go from here to this value, not including that value. Then each time through, I'll print out a list at bucket I. So this says, give me the value that lives in a list at this position. So the first time through, it'll say, show me whatever's at position 0, then position 1, then position 2 in this example. So there's your cat, dog, and elephant. Go ahead.
I have a question.
Okay, go ahead.
Would you be able to, so like when you did that, like that same like search for like the A string, are you able to do that, but for the list? If that makes sense, like with like the, just
So
like
you want
the
me to go through every
characters?
element of a string?
Yes.
So can I
Well,
do that, is what you're asking?
no, I don't think so. So like, so you know how we went through, like it goes through like every single character of the string?
Yep.
Are you able to go through every single character, but like through the list instead of just the like the collection of strings?
You want to get the C, the A, the T.
Yeah.
Oh, yeah.
Yeah.
So you would have to go one more level in, because right now what we're looking at is a list at bucket I is a string. So now if I want to get every character in that string, I would have to have a loop. So maybe we say for J in range 0 to the length of a list at bucket I. And then I can print a list at bucket I, which is a string, at bucket J. So the first time through this loop, we'll get the string cat. Then I'm going to say, now that I have the string cat, which is stored in a list at bucket I, that's cat this time through, I'm going to print out the C, the A, the T. So I'm printing out, this is cat at bucket 0, at bucket 1, at bucket 2. Then it'll spin back up. I'll get the string dog. So now for each character in dog, bucket 0, bucket 1, bucket 2, because it has 3 characters in it, I'll print out dog at bucket 0, dog at bucket 1, dog at bucket 2. Next time through, I'll get elephant, 8 characters. So this will give me all of the characters in those individual strings.
Okay.
So this wasn't some sort of magic trick. This was inside of this for loop. A list at bucket I is a value. this value is a string. So, you know, I can call this guy current string is equal to that guy. And then maybe this looks a little friendlier down here if I refer to it as current string, and then I print out current string at bucket J. So each time through this outer loop, I'm getting whatever the current string I'm looking at is. The first time it'll be cat, then it'll be dog, then it'll be elephant. And then I'm going through every character in that string. Does that make sense?
Yes. Thank
and
you.
then there's another question in here. All right, so, but the idea here is we're using this for loop to go through every element of this collection, where those elements can be all sorts of things. They can be numbers, they can be strings, they can be characters, they can be Booleans. So we can think of lists, and in some other languages, lists are referred to as arrays, but in a lot of our C-based languages, arrays are actually kind of primitive types, where lists in Python are a little bit more powerful than that. They're kind of object types. Not that important for us, but I just kind of wanted, from a vocabulary perspective, later on when you learn about arrays in the next class, they will seem extremely similar to lists in Python, but they're not quite as flexible as lists are. You kind of have to do some extra stuff to get all of the little features out of an array as you can get out of a list by default. But the punchline is that generally speaking, what is a list? A list is a collection of stuff, whereas a string is specifically a collection of characters. All right, and it might be reasonable that in our programs, we might want to have a collection of things that we want to iterate through. Does that make some sense? Now, another cool thing, now this will break under what I'm about to do here. I'm going to say this is a cool thing, but also might not necessarily be a helpful thing. So let's say I want to store in here my first name, my last name, and I'm going to store this actually as a number, and my age. All right. Now, I haven't designated these guys as being those values. I just happen to create a collection of elements, and I put in a string, another string, and a number. Okay. And I'm going to go ahead and I'll print out each of these guys. And we get Mike Littman 21. All right, so it is going through this collection of stuff. Now, I think this is a little bit dangerous, ever having lists like this. Typically, when we define a list, or synonymously an array, even though I said they're not quite the same, but when I'm teaching about them, I'm talking about a collection of things. Typically, we would say it's a collection of things of the same type. So if I'm in one of these compiled strongly typed languages where types matter, when you create an array, you are stuck with saying this is a collection of numbers, or this is a collection of strings, or this is a collection of floating point values, whatever it is. You have to specify that this is a collection of a specific type. Now, you can sort of kind of get away with what we did here by having a collection of objects and writing your objects in a certain way, but let's not worry about that right now. We're not at that point. So for our purposes, if we're thinking about arrays in other languages, they usually limit you to have a collection of all the same kinds of things, all the same types. Whereas Python, because it's a loosely typed language, it doesn't care. It'll let you have mixed collections. So I have a collection of 3 things here. The first thing is a string, the second thing is a string, and the third thing is a number. Now, that's all fine and good, and it lets you do this, and we can kind of say, well, what if I want to store 3 pieces of information about a person? And I don't know enough about programming yet or object-oriented stuff yet where, you know, I kind of want a single variable that just holds on to those 3 pieces of information about a person. I'll just remember that bucket 0 is their first name, bucket 1 is their second name, and bucket 2 is their age. I'll just remember that. Only 3 things, not the end of the world, right? we're going to say not the best way of solving problems, but humans, we're pretty smart. We can remember 3 things. All right, but we don't want to, you know, forget that the first name is at bucket 0, and if we assume your age is at bucket 0, we will start working with our data incorrectly. But, you know, we can pull something like this off. But one thing we want to be careful about is if I say print out the length of whatever I'm looking at bucket I, the length of Mike is going to give me a 4. The length of Lippman is going to give me a 6. Well, what's the length of 21? But that's not a horrible guess, right? You might say, okay, well, maybe it'll treat it like a string and it'll say its length is 2. But what does it do? It says, look, numbers don't have lengths. They're values. Okay? But what we're actually seeing here is an interpreter working in action. This is evidence that an interpreted language gets executed during runtime. The first time through it worked. I got the 4. The second time through it worked. I got the 6. The third time through, I ran into a roadblock. It says, look, you tried to take the length of something, and that something this time around was a 21, which is not a string. That's a number. And what's the length of a number just doesn't make sense. That question doesn't have a sensical answer. If I had changed this to the string 21, now we have a length of 2 and everybody's happy again, right? So we're back in business. But because I mixed types in here, and I said, oh, well, I'm going to store these 3 pieces of information because that's kind of how I want to compactly store some information about a person. You got to be careful that you're performing reasonable operations and all those types, because, you know, 21, you can't take the length of. And if for some reason you want to have the length of each of those elements, you're going to have a problem. All right, that makes some sense? So kind of an argument for maybe never doing something like this. I'm going to show you an alternative to this today. But in general, we might say this is poor programming practice to store mixed types of values inside of a list, even though it's perfectly legal in Python. Strongly typed languages, because of the nature of them relying on types, will not let you accomplish this. Okay, but for our intents and purposes, when we think about lists in here, we really want to think about collections of things. I would throw in the caveat of it's a collection of like-typed things. And if you always view it like that, you'll probably write better programs, better code. And if you need to hold 2 different kinds of things, then maybe look at a different structure for accomplishing that. Okay, so questions about lists and going through them, and you know, the thing we had a few minutes ago where we had 2 for loops here. Don't get into the habit of thinking that, oh, that's like this extra difficult thing. Each time through here, we have a value, and that value is a list at bucket I. Whatever that value is, now that's a value. Could be a string, could be a number, could be a whatever, right? I have a value that I can do things to. Now I can certainly just print that value if I wanted to, but if this value happened to be a collection of strings, if I knew that I was storing a bunch of strings in here, in that case, I know that a value is a string. And if a value is a string, I know that I can do things to strings. I can print out the length. I can print out the string. I can print out the string 1 character at a time by writing another loop that goes through each of the elements in that string 1 character at a time. I'm operating on this value, whatever that type is. Okay, it's not some sort of magic trick where you have a loop inside of a loop and a bunch of crazy magic stuff happens. Once I have this value, I can do things to this value. I just need to be careful I don't reuse the same variable. I is already being used to go from bucket 0, bucket 1, bucket 2. So if I want to do something to this value here, I need to use a different counter so I don't confuse those 2. Or if I'm just trying to get the characters, I can say for C in a value, print C, and that's our for each loop. So each time through, C will be one of the characters in a value. So there's my Mike Lippman 21. all right? But treat this part of the code as being separate from this part of the code. If you're walking through this, what I have highlighted right now, that takes I on a journey between 0 and 2 in this particular example. There's 3 things in my list, so this is going to be 0, 1, 2. That's what that for loop does. How I use I is up to me. I happen to be using it to extract a single value from my list. And then I'm storing that value in this variable. Then I'm doing something with that variable. Okay? So this is not a memorization thing, this is a problem solving thing. I've identified the kind of animal I'm dealing with here. It's a string in this case, because I happen to decide I'm going to store all like types in my list. Okay. So we've looked at lists. There is an ability to combine lists just like strings. We can concatenate lists together. I'll just show it real quick. So I have 2 individual lists, a list and another list. I concatenate the lists together, and I'm stuck with a list with all those elements in a single list. Realistically, this is going to be kind of a special case that you might need something like this, but it's a tool that you now have for what it's worth. Make sense? Okay. Let's say that we want to write some code. Now, I'm going to kind of shift our syntax for our, well, let's write a function first. So we're gonna write a function. So I'm going to define something. And we're going to define something called add nums. And this guy's going to take in an A and a B, 2 parameters. Now, we haven't looked at functions yet, right? We haven't written functions yet. All right, so I'm getting a little ahead, but we're going to use this in a little bit anyways. All right, so I want to create an ability. And I'm going to call this ability add nums. And this guy is going to return those 2 numbers added together. I'm going to write another function here called print nums. So let's call it print sum of nums. All right, so I have 2 separate functions here. We're going to see this run in a second. This first one's going to take in, these are inputs. So the name of my function is add nums. It requires 2 inputs that I happen to have named A and B. You can call them elephant and woot if you want. But whatever you name them up here is how you will use them inside of the body of the function. And what this guy does is he returns the sum of these guys together. So it's like when you call him, he spits out the answer. Okay? So if you gave me a 3 and a 5 and I calculate in my head inside the function that the answer is 8, I would then hand you the result. And you can do whatever you want with that result, but I'm returning the result to you. The second one, the print sum of nums, doesn't actually get you the result. It has me announce the answer. So if you gave me a 5 and a 3 for this one, I would print to the screen 8. So you can see it, but I didn't hand it to you for you to operate or do other things on it. So the lesson here is that when we start using functions, there is a distinct difference between a function that displays something and a function that returns something. Now you could have a function display and then return it. So hey, here's the answer, and oh, by the way, in case you need that value later on, here you go, you can operate with it. So whenever I say return it, I'm handing it back. Okay, and we'll see some examples of that, but that's a common issue that beginning programmers run into, is that difference between a function performing a task and giving you the answer for you to do with what you want, as opposed to performing a task and just displaying it onto the screen. Having it on the screen is great. We see a result, but we don't have that tangible value to do stuff with. Okay? Now, if I were to run this program right now, what will happen? Well, what's A and B? Well, so here's the issue. These are untapped resources. Every one of you in here, I presume, as long as they don't give you numbers that are too large, I could hand you any two numbers. You could add them together and either write your answer on a piece of paper and hand it back to me, or yell out loud what the sum is, as long as there's not crazy numbers, right? We all have that innate ability. But until I call upon that ability, it's an untapped resource, right? It's in your head somewhere, just there. So this is kind of this ability that's in the computer's head, if you will. But until I actually call upon that ability and give it two numbers that I wanted to add together, it won't do anything. Okay, so I can come down here and I can say, add nums 3 and 5. I'm calling upon that ability right now. Make sense? So now what will the output of this program be? Okay, it's still going to be nothing. Why is it going to be nothing? Yep. Well, this guy did return something, right? So I called upon add nums. Add nums requires two inputs. I named them A and B. So I passed this 3 in for A. I passed this 5 in for B. It took 3 plus 5, added them together. That gave me an 8. What did it do with that 8? It returned it. That's that thing like writing it on a piece of paper and then handing it to me. I get to choose what I'm going to do with it. What did I do with it here? Nothing. I can choose to print it if I want to. And now I'll get my 8. I can choose to store it. So I can maybe say the answer is equal to add nums and 14 and 218, something like that. So I'm calling upon that same ability, but I'm giving it different inputs. 14 is coming in for A. 218 is coming in for B. It's going to add those guys together, and it's going to return the result. What am I doing with that result? I'm storing it in a variable. So the output of this program is going to be still just 8. I am storing it in a variable, but I'm not doing anything with that variable. I have it. I can use it here in a few minutes. I can use it for some future calculation. I have the answer, but I haven't done anything with it, so I still just have an 8. If I want to display it, I can then say print the answer. And now I get my two different sums, 232 for the second one. All right, make some sense? Go ahead.
So what about that second line where it says print sum of nums?
Yep. Well, we haven't called it yet. Another untapped resource. Okay, so you have two abilities inside your head. One of those abilities is I can give you two numbers and you'll hand me the result back. That's what this first one kind of is. The second one is I can give you two numbers, you'll add them together and like shout the result out loud for everybody to see, but I don't get to do anything with it in the future. So at this point, I'm not actually calling this guy, but I'll go ahead and call it. So we'll call print sum of nums, and I'll pass this guy 21, and I'll just bang on the number keys a little bit, and 341. And it'll go ahead and it'll print that result, because that's what print sum of nums does. Not because its names has the word print in it, it's because this guy takes in two values, it adds those values together, and it prints that result to the screen. That's what that ability does. Does that make sense?
Yeah.
All right, so now what would happen if I tried to print the result of calling print sum of nums? Does this guy return anything? He does something. This is where I'm really driving that point home about the difference between functions that do something and return a result versus functions that do something but don't actually hand you a result. This guy returns that result. This guy does not. Make sense? So I am trying to print here the result of calling this function. That function internally does something. What does it do? It prints out the sum. But now I'm also going to print out whatever this function returned. And what did this function return? We don't see a return statement in there, right? So is it fair to say this function returns nothing? That seems to be a reasonable, and the value for nothing in Python is something called none. So we'll get this value none returned from that. Nothingness, empty. Okay, that's not the string none. That is, in some languages, it's called null. A lot of C-based languages, C, C++, Java, C#, N-U-L-L, all lowercase, is the nothing value. Okay, Python, it's none. We can't say the length of none. It's not a string. This is their way of representing nothing. Okay, so if you get something none printed on your screen and it wasn't your intention, probably like it was our intention this time we were expecting this to be our result. But if we get it and it's not our intention, chances are you didn't return a value you expected to return or something along those lines. Now I can print out some values and then I can still return, I don't know, let's just say a -5, just cuz. So now I can have print sum of nums, takes in two numbers, adds them together, displays the result, and then just randomly spits out a -5. Okay, so now instead of getting none here, I'll print out the result of calling this function, which happens to be, for no good reason, a -5. So there's my -5, because that's what that function returns. So there's a difference between what a function does and what a function boils down to. I use that phrase often, boils down, what it returns. So when I have this line here, I might say, what is that boiled down to? It does some things, it prints something here, but it ultimately will boil down to a -5 because that's the value that's returned from it. And I am going to print out whatever this guy resolves to or whatever he boils down to, which in this case is a -5. Go ahead.
Different types within these as well, like you said, do you return like a string value?
Oh, absolutely. And you shouldn't avoid using different types here. So if I want to like display a name, and this guy takes in a first name and a last name, and I decide I'm going to print a first name concatenated with a space, concatenated with a last name. And then I go ahead and say display a name, and I pass it Mike and Littman. It will take in Mike for a first name, it'll take in Littman for a last name, and it'll display them as these two strings concatenated with an with a space in the middle. So there's my Mike Littman. If I also want to throw in a age, so maybe we change this to display a person. And this is kind of what you were getting at, is maybe we take in two strings and an int in this case. That's what the inputs require for this. So a function does something given the inputs you give it. All right, if you're an auto mechanic, you come in and you have a string request, you want an oil change, let's say. And then you also have to provide some money, and then the mechanic will go and do the work, right? So you need to give them two different pieces of information there in order, or two different pieces of stuff for them to accomplish the task. What do you want? And the money for doing it. Make sense? So our inputs here is what is it going to take? What does this guy need in order to do his job? So I'm actually going to build this as an F string. Remember, we have our placeholders, so I'll do a space there, and I'll do a little dash and say age colon, and this will be a first name, a last name, and age, so that makes it a little bit cleaner to build formatted strings. Do be careful though, I know some of you have been having some issues with your virtual machines, so I've told you to like use like online Python interpreters just for now as you're doing your homework so you don't fall behind. And one of them I did on my phone the other day for putting your solution to your homework assignment up. It didn't allow F strings. So it must have been an older version of Python that was on there prior to F strings being included. That's why I wrote it out the way I wrote it out instead of having one single thing. But F strings are certainly part of the current Python standards. We just put a little F before the double quotes, and now we can put these placeholders in there in the curly braces. Now, if I call this right now, notice it, oh, I need to call display a person. Okay, it tells me, hey, this required an extra argument, age. I didn't give it. So display a person is requiring 3 inputs. It wants me to give it 3 things. I gave it 2 things. So now I can go in and throw that 3rd element in there, and then it'll display that information for me. If I want to display a different person, I'm calling upon the same ability, but giving it different inputs, and it will put those guys together in that formatted way. Because that's what I wrote in the function. The logic I wrote was to format a name and an age together to give some sort of pretty print kind of string that looks reasonable way of putting those values together. But again, if I were to print the result of display a person, this guy in here boils down to whatever this function boils down to, and this function does something, but it does not return a value. So I'm going to get a none for that last part. Lesson here is that functions functions should always do something, otherwise why should it exist? But secondarily, functions do not have to return a value, only if it made sense for whatever you're trying to write for your function for it to return a value. All right, go ahead.
So like if I just do like print display a name, like the variable display a name, it says something weird like function display a name.
That's because that's what, so display a name is a variable whose value is something called a lambda expression. So its value is a function. So what he did is he printed out, in my case, display a person. So print the value of display a person. I defined something up here called display a person. And this guy is equal to a function that takes 3 parameters and does some stuff. So this says, he's a function called this that lives at this place in memory, and he does whatever he does. It's showing you the value of that function. Probably not a whole lot of benefit in that. You're just kind of seeing what's under the hood a little bit. Because when I defined that function and say, okay, here's this untapped resource that we might need to use later, right? We might need to use this later. So I need to put this somewhere for later usage. So I put it at this memory address. So I have this display a person thing at this memory address, and then right down here, I said, I'm going to go ahead and call upon that guy and give it the inputs that it required to do its job. And then Python will go to that memory address, passing it those 3 inputs and get whatever it gets from it. Does something, returns something, does something and returns something, whatever it is. All right, that makes some sense? All right, so the things I really want to drill home here, these are kind of common issues that beginning programmers run into, is really starting to think about when you write some code, what does that code actually do? What is your expected result? Now, early on, you're going to probably do a lot of trial and error where you're going to, hit the play button and see what happens, that kind of stuff. But I really encourage you to always ask yourself out loud, what do I expect the result of what I've written here to be before you hit play? And then it might live up to your expectations, it might not, but with practice, that will make you a better programmer, because what you don't want to do is you don't want to do the trial and error thing where you've done every permutation of some kind of math until you finally get the right result and you don't know why. Like, I tried 15 things and this was the one that worked. I don't understand why, but this is what I'm submitting. Now that's fine, that gets you past a homework assignment, but you've probably already noticed that I don't grade the assignments very difficultly, right? Difficultly? I'm a fairly easy grader as long as you put in the effort. Difficulty sounds like it should be right, but it doesn't sound right. No, that's definitely not right.
No, I know.
That's missing letters. I don't punish you for hard work, right? I want to encourage you to do the work, and I'll punish you on the exams. And I even give you a redo on the exam, right? You bomb the midterm, I'll let you fix it with the final. So at the end of the day, I want you to keep drilling so you eventually get this stuff. But when you're doing your homework, the goal should be to learn, not to get the correct answer. Correct answers are great. That's a confidence booster, right? But the journey is far more important. When you spend 2 or 3 hours on something stupid that you then see in class solved in 3 minutes, it was that 2 or 3 hours that you spent was where the learning occurred, not the last 5 minutes when you finally got it to work. That was the icing on the cake, right? That was finally, that was it, something like that. So value those the reps that you were putting in, because that's where the learning is actually happening. All right, so rule of thumb here is before you hit play, always kind of go through this exercise of what do I expect to see as a result on the screen. Make sense? And get into that habit. And eventually you won't have to do it anymore because it'll come very naturally. Okay, go ahead.
I just have one more.
Sure.
Oh, so when I did return under depth display name, but then I gave it I didn't actually put quotations on it. I gave it a variable name that didn't work because I didn't name the variable.
All right.
Now it does print the string if you make it.
Oh yeah, I mean if you mean if you do this?
No, like up there. Underneath depth display name, the function.
Yeah.
I put a return value of Nick, but I never made a variable Nick because I didn't put a string around it.
Right. So you said this. And that way when you print it out, well actually it still wouldn't work down here. Well, it didn't work because this guy expects me to give it some parameters. So I can, there's the Nick right here. I printed the result of this guy giving it some parameters. If I just say print out the value of that function, it says, this variable boils down to a function. We don't know what that function does, but hey, this guy is a function. This is just how Python's representing it. I've stored a function somewhere. Where? Right here. And that's a big, scary, what kind of value is this? It's a hexadecimal value. Looks scary, right? But the way things are stored in memory in a computer is everybody lives on one long street. Okay? In real life, we have very complex memory addresses, but they're far less intimidating, right? We have a house number, a street number, a town, zip codes, things like that, right? We have all these things that are part of our real life addresses. Give me the address of the restaurant we're meeting at. You punch it into your GPS and it takes you along all these zigs and zags until you finally get there. Human versions of addresses are complex. they don't seem scary. We've been dealing with them for years and years and years and years. This guy here looks intimidating. It's just a number. We won't go through the process of converting that because it'll be a really big number, but that will translate to some decimal number, right? Some big, big, big decimal number. That means, where are you asking me to go? I'm asking you to go to house number 27 million down the street. Everybody lives next door to each other. Super easy addresses, right? Everybody lives in the same town. They live on the same street. You just better, if you're walking, you'd rather visit one of the first few houses, not the guy way down there. But computer memory is very, very easy. It's all one big long street. Go to house 2, go to house 5, go to house 7, go to house 21 million. All on the same street. It just looks intimidating because it's working with number systems that allow us to represent this giant number in a smaller footprint. That make some sense? Okay. All right, so questions about functions and the idea of a function that does something versus a function that returns something. Go ahead.
We can return a separate variable as well.
Well, I did right here, right? This guy does something and then returns something.
Right, but we can return a different variable, right? Like a variable, we can return a list if we have a list of numbers.
Sure. I mean, I could say LOL is 1, 2, 3, and then I can return LOL. Yeah, because I mean, the thing is, this isn't some limiting factor. This guy returns a value. What value? It's whatever this variable boils down to. What does that variable boil down to? It boils down to this list. Is that list a legal Python type? It is. So display a person now does boil down to, I'll go ahead and get rid of this last one because that's not something you do ever. But now I get a list as a result of that. But if I want to print out the length of that list, for example, now I'll get a 3. Because that's how many elements are in the list that this guy returned. If instead I want to print out bucket 1 of that list, this guy will boil down to a list. I'm saying, give me the value that lives at bucket 1 in that list, which is the 2. Because this is bucket 0, this is bucket 1, this is bucket 2. So bucket 1 is a 2, and there's our 2. That make sense? So you got to go through that process of saying, what kind of animal? Now, the more things you kind of tack on here, the scarier this line looks, right? Because when you first look at this, like, okay, well, he just randomly has this square bracket thing at the end. Is that some kind of new magical syntax? It's the same syntax you've seen all along. But what you haven't done, though, is you haven't said, what does this boil down to? That guy I have highlighted there boils down to, we know, this value right there. And that's a list, the list 1, 2, 3. And if I have a list and I say, give me the value that lives in index 1, I get the value that lives at index 1 in that list. Now, usually we do things, we create like a list is equal to 1, 2, 3. Well, actually, we probably write it this way. We probably say a list is equal to the result of calling this function. And then we could print out a list. Similarly, we can print out a list at bucket 1. And we get our a list, and then we get a list at bucket 1, which is our 2. And we say, oh, well, we wrote it this way instead of just grabbing bucket 1 of this guy. If I grab bucket 1 of this guy, now a list is a 2. And what is a list at bucket 1? If I have the number 2 and I try to take bucket 1 of the number 2, what do we expect the result to be? So you have this value right here, 2.
Would it be none?
None would be a very friendly way of telling us that what you just asked us doesn't make sense. So in this case, it won't be none. I think we're going to see some red text. But none's not an unreasonable, you're basically saying, look, this doesn't make sense because I've given you the number 2 and I'm saying, give me bucket 1 of the number 2. Number 2 is a number, it's not a collection, right? So when I run this, we're going to get some red text that says, look, you've tried to get the subscript of something that's not subscriptable. An int, like a 2, is not subscriptable like a list, like a collection. All right, but if we go back to this guy, I take that off the end. Now we're storing inside of a list the list that is returned by display a person. I'll go ahead and print out that entire list. And then I'll print out bucket 1 from that list. But if we're going to practice this idea of resolving that, when this line goes to execute, a list is the name of a variable. So that guy boils down to his value. That's what ultimately gets put there. A list resolves to its actual value, which is the list 1, 2, 3, of which I'm saying, give me bucket 1 or give me bucket 2. Bucket 2 will give me the 3. All right, so we want to get into this habit of saying, here's what I've written. What does it resolve to and what do I expect the result to be? It's an important thing for us to practice as our programs are going to get more and more complex. All right, make sense? All right, so let's do it on time. We're out at 11:20, right? No, I think it's 11:20. Right, 11:20? All right, so I want to introduce a new collection type, and it's something called a dictionary. Now, this is actually a pretty valuable tool because how many of you have ever heard of something called JSON? I think I maybe mentioned it on one of the slides or something, but have we heard that term before? Do any of us know what JSON is?
It's this
That's true. Friday the 13th. What is it? Jason's your dad's name. Okay, we got serial killer and a bunch of wise guys in here today. Yeah, it's JavaScript object notation. So this is how the JavaScript programming language represents objects. And we're going to see that the syntax for dictionaries, well, actually, we'll learn the syntax for dictionaries, then later on, we'll see how it actually directly relates to JSON in a identical way, really, and we'll see how to process it like JSON. But you know, XML is another one of those vocab terms. XML and JSON are ways of organizing data so that we can pass them around. In this case, a dictionary is a way of organizing values that don't have the same types. So for instance, what I'm going to do is I'm going to create a person, and this person is going to have a first name that is Mike, a last name that is Littman, and an age that is 21. So dictionaries are built using the curly brace syntax, curly brace notation. So I'm creating a collection of name value pairs. So the first name is associated with the value Mike. The last name is associated with the value Littman. The age is associated with the value 21. So I've created a new type of collection here called a dictionary. And now if I want to use this guy, I can say a person at bucket F name. So instead of saying at bucket 0 or at bucket 1 or at bucket 2, I'm saying give me the value associated with the first name for a person, which will give me the mic. So there's the mic. If I say instead, give me the value associated with the last name, it'll give me the Littman. If instead I say, give me the value associated with the age, it'll give me the 21. Now, one thing about dictionaries is they do not guarantee the order. So even though I've put these guys together with the first name being first, the last name being second, the age being third, if I were to go through this dictionary, it does not prompt with some kind of loop, and we'll look at those in a few minutes. But if I were to loop through this dictionary in some way, I would not be promised that the elements would show up in that order. But that's okay, because that's not the intended use of a dictionary. The intended use of a dictionary is I look up a word and I get its value, just like a dictionary, right? You look up a word, you get its definition. Okay? So it doesn't intend for us to care about the order in which these are actually stored. Realistically, depending on the implementation of the Python interpreter, if you were to loop through, so here, I'll just show you real quick. I'll say I'm going to call it a key in a person, print a key. And we get first name, last name, age. So we get those keys, the name value pairs. We get the first name, the last name, and the age. It just so happens that they were in the order we put them in there. I built it with first name, last name, and age. I happen to get them in that exact same order. All I'm saying is that we are not promised that that's a truth. We're up to we're at the mercy of the people who wrote the interpreter if that's the way they want to internally store it. So it's not the desired way of working with it, okay? But now that I have that key value, I can then say, okay, well, I want to print out a person at bucket a key. So this will go through and it'll show me all the values associated with that person, because this loop, this for loop, goes through all of those key values associated with this dictionary. So I say name value pairs. You could also say key value pairs. So you can think of this guy as a collection of variables and their values. So this loop, when I use a for each loop with a dictionary, the value I get is the value associated with the variable names, the keys. And then I can use that key to extract the value associated with that key from there. So now I'll get the first name, the last name, and the age, but the values of those. So there's the Mike Littman 21. That make sense? So dictionaries allow us to hold collections of information where the order is not important. Instead, we want to hold, like earlier I said, oh, maybe we have a list. And in that list, we put the first name, the last name, and the age. And we just will remember that the first name's at bucket 0, and the last name's at bucket 1, and the age is at bucket 2. In this case, we don't have to remember that. We just know that the first name is at bucket F name. In older languages like Perl, this type of thing was called an associative array. So instead of saying bucket 0, bucket 1, bucket 2, we would say, give me the value associated with this index. You have a question?
Oh, yeah. So if you want to print them, I can't really think of a situation in which you need this, but if you want to print all three of them out, like bucket 0, 1, and 2, could you just put age, last name, and first name?
Oh, you mean like all at the same time?
Yeah.
You could build a string that does that. You know, you can build up a string that would have all of them, or you can just print the dictionary. But here, let's do this route. So let's call it result string. We'll start off as the empty string, and we'll go ahead and say result string is equal to whatever result string is currently equal to concatenated with, let's just throw a space on there. And then concatenated with a person at bucket A key. And actually, maybe we really want to have the value in there. So maybe we say A key, and then we say equals a person at bucket A key, something like that. So now this loop will go through and build up this result string. The first time through, it'll be first name equals Mike. Then it'll have a space, first name equals Mike, space, last name equals Littman. Then the next time through, it'd be first name equals Mike, last name equals Littman, age equals 21. Then after this loop is done, I can go ahead and print out the result string that I built up as I went through there. Lowercase a. So there's my first name equals Mike, last name equals Littman, age equals 21. So I can get the values, but I have to put them somewhere. So what you were suggesting is, well, can I say print out a person at bucket F name and at bucket L name? Something like that. I want to extract two pieces of information at once. Not happy with that. Yeah, so if you want to do that, you have to kind of put them somewhere. I'll go through and get this value, then I'll go through and get this value, and I'll store them somewhere, and now here's your two pieces of information. Something like that. Okie dokie. Actually, let me... Still an error, but now it's the correct error. All right, so we understand how dictionaries work. Key value pair type things. Okay, well, you're going to need dictionaries in your homework assignment for today. Let me just talk about that real quick, and then we'll spend a few minutes starting to write something else. So you're going to write a program that stores in a dictionary your first name, your last name, and your age, and displays to the screen a sentence containing the person's full name and age. You should accomplish this using traditional string concatenation as well as F strings. So something pretty similar to what we did today, but combining that with F strings. Okay, so it shouldn't take too long, but it'll get you working with the syntax for dictionaries and get you working with the syntax for F strings. Go ahead. Whatever, just some reasonable format. So containing the person's full name and age, whatever that format you deem is most appropriate. As long as you use an F string to create an interesting format, and as long as you use a dictionary to store the information, you know, you're in good shape. All right, so now I want to introduce a new format for our programs. Now, one truth, I'll go ahead and put this in a slide. When we talk about actually not even modern programming, when we talk about computer programming starting from the late 60s, so really I'm talking about from the C programming language, but really it started before that. I'll just call this a truth. All programs begin and end with main. So I'll just say where main is the function that is automatically called when a program runs. Now, sometimes main might be called something else, or sometimes if you're using, like for instance, if you're an Android developer, main, I promise, is hidden at some like 6 layers down that you never actually interact with, but it's there. Your first interaction point as a Android programmer is going to be inside of a function called onCreate, which calls 3 other functions, which call 2 other functions, which ultimately call main. Okay, so it is happening. So this is a truth that all programs begin and end with main. We're also going to be talking about something called scoping rules, which is where do we have access to the value of a variable. Now, unfortunately, because of the way Python is structured. Right now, we have this thing here. Let me actually just put it, let's talk about scoping. I probably have it someplace else, but so if we talk about scope, scope is, I'd ask the audience, but I think we're going to get the mouth rinse. Is there another serial killer named Scope? Probably is somewhere. All right. Freddy Krueger is better than Jason, by the way. Well, at least we can agree on that. Although, have you seen the movies, Nightmare on Elm Street movies? Yeah, because those are, we need a remake of those. They keep remaking everything else.
Yeah, that would be a good remake actually with like better CGI.
Oh yeah. Yeah, people never sleep again. It'd be awesome. Like literally. All right, so, but scope, when we talk about variable scope, in fact, I'll actually throw that in there. Just variable scope is, this is where we have access to a particular variable. I'm going to draw a picture of what we have going on right now. Is we have, when we don't do anything else special, we have this global scope. I'll make that guy yellow. All right, so that's the global scope. Now in our current program here, we've created a couple of functions. So we have add nums, we have print sum of nums, and we have display a person. So this is add nums. Print sum of nums. And display a person. Okay. And then we have some variables that we've already defined. So we have the answer, we have a list, we have a person, we have result string. So we have answer, a list, a person, result string. So these are variables that were defined as part of the global scope. Go ahead. Yes, it is, but it's actually part of the scope of that for loop. So, you know, we can put one more thing in there. So we actually have another scope called for the for loop that has a key in it. So if we come after that for loop and I print out a key, oh, I need to get rid of our error message there. Actually, it doesn't handle for loops as their own scopes. A key still had its very last value, which was age. So a key is part of the global scope in this case. So these are all variables that are part of this global scope. Now, add nums has a local variable a and b. Print sum of nums also has a local variable a and b. And display a person has a local variable, a first name, a last name, and age, as well as another one called LOL. So a first name, a last name, age, and LOL. Okay, so this A and B here, all variables resolve to their most local definition. So the A and B that's right here are in separate worlds than the A and B that's right here, or separate scopes. So these two guys, these two variables A and B, do not contradict each other. But if I were to print out an A inside of display a person, it's going to print out none, or say it hasn't, you could probably say it just hasn't been defined. So let me go into display a person, and I'll say print A. All variables resolve to their most local definition. So is there a variable named A defined in here? No. The next level up from this guy is not one of these. It's this yellow environment, the global environment. So we see here that we get an A is not defined. So even though we have A defined here in this scope, and we have A defined here in this scope, as far as display person is concerned, it doesn't have a variable called A defined locally. The next place for it to check is the environment in which it lives in, which is the global environment, which also does not have a variable named A. Does that make sense? This is how scoping rules work. So variables resolve to their most local definition. So if I did have a variable in my global environment here, A is equal to woot, and then run this. Where's my woot? There's my woot. There's my woot, because I called that function twice. So now it looked for A. It did not find it here in the local scope, but it did find it in the global scope, even though I defined it afterwards. This was an untapped resource, but it didn't get called until this guy already existed. All right, does that make some sense? So next time we'll start off, somebody remind me, is we're going to create a new structure for our Python programs where we'll actually artificially create a main method, so that this truth that all programs begin and end with main will be solidified for us, so that we move to different languages, we're already in that right mindset. Okay, so I'll put the homework assignment up for Tuesday. Shouldn't be a difficult one. We basically did it in class today, but again, as you're practicing this stuff, try to get yourself into that habit of, before you hit play, what do you expect the result to be? Sound good? Questions, comments, concerns, bribes? Once again, I do apologize about Tuesday. I was not a happy camper about that, but is what it is.